Okay, questions 13 and 14 are similar. They you do effectively what you did in question 12, where you find the area between two curves, the area between two functions on an interval. But they both deal with a surplus at market demand and market price. That those are also referred to as equilibrium price and the equilibrium quantity. And in the first of these two questions, in question 13, you have to solve, you're given the market price. The P with the bar above it is the market price or the equilibrium price, and you have to solve the price-demand equation to find the market quantity, to find the equilibrium quantity. Well, the P, the price, the market price that you're given is $35, and so we substitute 35 for P, and that's going to be equal to 50 minus 0.75x, and so we set up that equation to solve for x, and that will give us our equilibrium or market price. So I have here subtracted 50 from both sides of this equation. That gives me negative 15. And then I've divided both sides of this equation by negative 0.75. And since this is a negative divided by a negative, that will give me a positive 20. And so that particular quantity is our equilibrium quantity, our market demand quantity of 20. So the formula for consumer surplus is the definite integral from 0 to x bar, the equilibrium or market quantity, of the price demand function, in this case 50 minus 0.75x, minus the market price, which, as we were given, is $35. Well, 50 minus 35 is 15, and so we evaluate this definite integral to find our consumer surplus. 15 minus 0.75x evaluated from 0 to 20. Now, to find this antiderivative, a constant term becomes a first degree linear term. We'll just add an x on there. And to find the antiderivative for this term, we remember that this is x raised to the first power, and 1 plus 1 is 2. So we will raise our x to the second power, 2. And the reciprocal of 2 is 1/2, and so we'll multiply this 0.75 times 1/2, and so that gives us 0.75 x squared over 2. Well, 0.75 over 2 is 0.375, and so when we evaluate the antiderivative, we will substitute a 20 for this x, so we have 15 times 20, and a 20 for this x, so we have 20 squared times 0.75 divided by 2, which, as I said, is 0.375. And so that value right there is going to be 300 for this term and 150 for this. And when you subtract 150 from 300, you get 150. And then, of course, the other limit of integration is 0, and this antiderivative evaluated at 0 is just 0. You plug a 0 in here and a 0 in here, and you're just going to get 0. That's the same situation you'll encounter on the question on the test, and it's also the same situation that you're going to encounter with the next question, producer's surplus. So everything that we did in question 13, we will repeat in question 14, except that the formula is a little different. And in this case, we are going to be given both the equilibrium price, the market price, and the market demand, the equilibrium demand quantity. And so you don't have to make this calculation right here for question 14. Those values are both already given to you. So producer surplus on a given interval is and for our question, the lower limit of integration is going to be 0. The upper will be the market demand, the equilibrium demand. And so those are the limits, and the integral is the market price, or the equilibrium price, 49, minus the price supply function, whatever that is. And in this case, it's given as 13 plus 0.009 x squared. And so there it is, 13 plus 0.009 x squared. The extra little bit that we have to watch out for that we didn't have to really worry about in consumer surplus is that this subtraction is going to get distributed to both the 13 and the quadratic term, the 0.009 x squared term. So our interval, or rather our integral, becomes 49 minus 13, which is 36, and negative 0.009 x squared. And then we find our antiderivative using the power rule for antiderivatives. This constant term, 36, becomes a first degree term. You just put an x on, tack an x on next to it. And then, excuse me, this 2 plus 1 is 3. And so then x is now raised to the third power. And the reciprocal of 3 is 1/3. And you multiply 1/3 times 0.009, and that gives you 0.003. So our antiderivative is 36x minus 0.003x cubed. And when we evaluate that expression at 100, we have 36 times 100 minus 0.003 times 100 cubed. Be careful, make sure that you only cube this 100 first before you multiply it by this coefficient. And so that'll give you 3,600 in the first term and 3,000 in the second, and the difference between those two is 600. And then, just as before, this term is going to be 0. It's going to it's going to evaluate as 0. I would still appreciate you writing this on your work if you have room, to let me know that you know what you're doing, that you realize that we're actually evaluating that antiderivative at both of these limits of integration.